So you just saw the IU video that went over the energy of solutions, and sometimes I hear people get a little confused. So I'm going to do a quick overview, and here's some notes you can add. You don't have to have these notes. You already have it in your workbook, but if you like this, go ahead and take it. So when we form a solution, 3 steps must happen. 1, 2, 3. The solute particles must separate. Let's think about sodium chloride in water, salt in water. The sodium and the chlorides have to start breaking apart, and that takes energy to do that. Now, you'll see in your workbook we have delta H and delta E. Those both mean energy. This is enthalpy, which is the energy, and delta E is just a generic energy. Okay, so they mean the same thing when you see that. Number 2, those solvent molecules, which is water, must separate so they can start grabbing on and pulling apart those sodium chloride ions, and that's also going to take energy, so a positive delta E. Now when the solvent and the solute finally come together, that's called solvation, and that's a lower energy, which means it's going to give off energy. Okay, so I need to add energy, I need to add energy, and then it's going to give off energy. If I add all 3 together, okay, and I get a negative number, that means it's going to give off energy and things will dissolve, okay, because we're going to a lower energy, which is what we want to do. And all you have to do is add that together and see what your overall energy of solution will be. Okay, so if it is negative delta E, it's giving off that energy, it's going to dissolve, it's exothermic, exo exiting the system. If it's a positive delta E or delta H, it's an endothermic solution, and that means we need to put energy goes into the system. We're putting energy into the system, and it probably won't dissolve. But there is one thing that if it's really close to 0, and it's still positive, remember we want an exothermic number, we might be able to overcome that with entropy, which is the energy of disorder. So the more random it is, the more mixed up it is, the higher the entropy, which lowers the energy. Okay, so solutions become more mixed up, which gives it a greater entropy, and this may allow a solution that's very close to that exothermic line to dissolve.